We hop in our cars every day and we just sort of think of them as, well, one thing, right? A
Yeah.
car.
Yeah, just a single unit.
But underneath that metal skin, there's this really fundamental structure, and that's what we're going to dive deep into today. Vehicle chassis design.
Mm-hmm. The skeleton, basically.
Exactly. And we've got some great source material here that really lays out the basics of this core component.
It's foundational stuff.
So our mission, if you will, is to kind of pull out the key ideas, the most important bits, so you listening can really get a handle on how your car, or any car really, is fundamentally put together.
And it's kind of surprising, isn't it, how these things that look maybe kind of similar on the outside can be built on totally different foundations underneath.
It really is. And we're going to focus on the two big ones you hear about most, body on frame.
And unibody.
Let's tackle body on frame first.
Okay, so body on frame. The name kind of gives it away, right? You've got a separate body structure mounted onto a load-bearing frame.
Right. Think of a ladder, a really heavy-duty steel ladder.
Yeah.
That's kind of the image that comes to mind.
That's a perfect analogy, actually. You typically have two long, strong steel rails running the length of the vehicle, connected by several cross members. That forms the rigid base.
And this ladder, this frame, it's doing the heavy lifting, yeah.
Yeah.
It's the main structural part.
Absolutely. It's the primary load-bearing structure. It holds the engine, the transmission, the whole drivetrain.
Okay.
Plus the suspension components, the steering system. It all mounts onto that frame. It provides the core strength.
Gotcha. So then the body part, that's the shell we actually see, the doors, the roof, the cabin.
Exactly. That's the part that forms the passenger compartment and holds all the exterior panels. It sits on top of that separate frame.
So how do they actually put these together in the factory?
Well, typically the frame gets built up first, often with the engine, suspension, and axles already attached. It's like a rolling chassis.
Okay, like a big skateboard almost.
Kind of, yeah. Then the completed body shell is literally lowered down onto this frame.
Wow.
And then it's bolted securely in place at various points. After that, they connect all the wiring, plumbing, everything that needs to pass between the body and the chassis.
Okay. So distinct frame, separate body, bolted on top. Got the picture.
Yeah.
What are the big advantages then? Why build a vehicle this way?
Well, the number one reason is usually strength and durability. That heavy, separate frame is incredibly tough.
Right.
It makes these vehicles really well suited for demanding use. Think heavy-duty work, serious off-roading where the chassis gets twisted and stressed.
Going big trailers, hauling heavy loads.
Exactly. That separate frame can handle a lot of abuse. It's just inherently strong.
Okay, that makes sense. And I think our sources mentioned something about repairs and modifications being easier.
Yeah, that's another key point. Because the body and frame are separate, if one gets damaged, say you bend the frame in an accident or you damage a body panel, you can often repair or replace that part more easily without it affecting the other major component as much.
Ah, I see. So you don't necessarily have to fix the whole structure if just one part is damaged.
Correct. And for modifications, like if you want to install a suspension lift kit for off-roading, it's often more straightforward because you're primarily working with that separate frame and suspension system.
Interesting. What about noise and vibration? The sources mentioned better isolation.
Yeah, this is because the body isn't rigidly welded to the frame. Instead, it's usually mounted using rubber or polyurethane bushings.
Okay, like little cushions.
Pretty much. They act as insulators, absorbing some of the vibrations and noise coming up from the road, the engine, the axles before it gets transmitted into the passenger cabin. So, in theory, it can lead to a quieter ride, isolating you from the mechanical bits.
And the big one for trucks and stuff, towing and payload.
Definitely a major advantage. That robust, independent frame provides the backbone needed to safely handle really high towing capacities and heavy payloads. The frame is designed specifically to bear those kinds of loads.
Okay, strong, repairable, potentially quieter in some ways, great for hauling. Sounds pretty good. But there have to be downsides, right? Engineering is all about trade-offs.
Absolutely. And the biggest one for body on frame is usually weight.
Yeah, all that steel in the frame must add up.
It really does. They are significantly heavier than vehicles built using the other main method. And that extra weight, well, it hurts fuel economy.
Right, more mass to move around.
And it also tends to negatively affect handling. They can feel a bit less responsive, less agile, especially compared to lighter vehicles.
Okay. The sources also brought up something about low crumple zone efficiency. That sounds not great from a safety perspective.
Yeah, that's a point that needs a bit of context. Historically, the very stiffness that made these frames strong meant they didn't deform as much in a crash to absorb energy.
So more force could reach the occupants.
Potentially, yes, in older designs. But, and this is really important, modern body-on-frame vehicles have come a long way. Engineers now design sophisticated crumple zones into the frame itself and integrate advanced safety features into the body structure too.
So it's not quite the black and white issue it maybe once was?
Definitely not. Modern ones are much, much safer. But the fundamental principle of absorbing energy through controlled deformation is arguably more inherent in the other design philosophy we'll talk about.
Okay. And the last con mentioned was poor ride comfort. But we just said they can isolate noise and vibration.
Yeah.
How does that square up?
Yeah, it's a bit nuanced. While those bushings help with some harshness, the fact that the body and frame are separate means they can sometimes move slightly independently of each other.
Like a little bit of shimmy or shake.
Exactly. On smoother roads especially, you might feel a less sort of connected or refined ride. The body might feel like it's floating or jiggling a tiny bit on top of the frame, which some people perceive as less comfortable than a more integrated structure.
Okay, that clarifies it. So to make this real for people, what are some common vehicles that use this body-on-frame setup?
Oh, lots of familiar names, especially in the truck and large SUV world. Think the Ford F-Series pickups.
The best sellers forever.
Yep, the Ford Bronco, the Mercedes G-Wagon, Toyota Tundra, Toyota Land Cruiser, the Jeep Wrangler is a classic example, Chevy Silverado, GMC Sierra. Basically, most full-size pickups and many traditional rugged SUVs stick with this method.
Got it. That really helps picture where this design shines.
Okay, let's totally switch gears now. What about the other side of the coin? Unibody, sometimes called monocoque.
Right. Unibody, or monocoque, which just means single shell, basically is a totally different approach. Here, the body and the frame aren't separate. They're integrated into one single structure.
One piece. So, like, the body is the frame.
Essentially, yes. The structural support doesn't come from a separate ladder underneath. It comes from the entire vehicle body working as a unit.
So where does the strength actually come from, then, if there's no big frame? It comes from the clever engineering of the body shell itself. Think about the floor pan, the roof structure, the pillars between the windows, those A, B, and C pillars.
The vertical posts.
Exactly. Those, plus the side panels, the firewall between the engine and cabin, they're all designed and stamped and welded together in a way that creates a strong, rigid box. They all contribute to the overall structural integrity.
Okay, so it's like an exoskeleton almost, providing the support.
That's a decent way to think about it, yeah. The shell itself is the structure.
And how do you attach the heavy bits, like the engine and suspension, if there's no frame to bolt them to?
They get bolted directly to reinforced points within that unibody structure. Engineers design specific subframes or strengthened areas in the floor pan or engine bay, for example, to handle the stresses from the suspension and powertrain.
Okay, integrated structure. What are the big wins for doing it this way? What are the pros?
The biggest advantage is usually weight reduction. A unibody structure is typically significantly lighter than a body-on-frame setup for a vehicle of similar size. Our sources mention potentially around 30% lighter.
30%, that's huge.
It really is. And less weight means better fuel efficiency, almost always.
Makes sense.
It also generally means better performance, quicker acceleration, shorter braking distances, just because there's less mass to get moving or stop.
What about how it feels to drive? Ride quality.
Generally considered better, especially on paved roads. Because it's one solid integrated structure, it tends to be stiffer overall.
Stiffer. How does that help ride quality?
Well, a stiffer structure resists twisting and flexing better. This means the suspension can do its job more effectively, controlling wheel movement precisely without the whole chassis flexing underneath it. It also helped absorb and dampen road vibrations more smoothly throughout the entire structure, leading to a generally more refined and less jiggly ride.
Okay. And safety. The
Yeah.
sources highlighted that as a major plus.
Yes. Unibody construction is really well suited for designing effective crumple zones. Engineers can precisely design sections of the front and rear structures to deform in a controlled, predictable way during a crash.
So they collapse strategically to absorb the impact energy.
Exactly. Absorbing that energy in the crumple zones helps slow the deceleration of the passenger compartment and better protects the occupants inside.
Makes sense. And handling was the other big pro mentioned, better cornering and stuff.
Yeah, that ties back to the stiffness again. A stiffer unibody structure resists torsional flexing twisting much better than a separate body and frame.
So when you turn the steering wheel,
The whole car responds more immediately and precisely. There's less body roll in corners, and the suspension can keep the tires planted more effectively. It just leads to generally sharper, more responsive handling. Think most cars and crossover SUVs.
Okay, so lighter, smoother ride, better safety through crumpling, sharper handling. Seems like a lot of wins for everyday driving. What's the catch? What are the cons?
The main drawback really comes into play after a serious accident. Repairing significant structural damage on a unibody can be much more complex and expensive.
Because the frame is the body itself.
Precisely. If those core structural elements, the pillars, the floor pan rails, the roof structure get badly bent or compromised, straightening them requires specialized equipment and skills. It's not like just replacing a bolted-on fender.
And I guess if the damage is bad enough.
It can unfortunately lead to the vehicle being declared a total loss by the insurance company, even if the rest of the car seems okay, because repairing that integrated structure properly is just too costly.
Ouch. Okay, that's a big consideration. What about heavy-duty use, like the stuff where body-on-frame excels?
Yeah, that's the other main limitation. While unibodies are strong enough for normal passenger car duties and even light towing or mild off-roading in crossovers, they generally aren't designed for the kind of sustained heavy-duty punishment that a separate frame can endure.
So probably not the best choice for hauling huge trailers or tackling really extreme off-road trails regularly.
Generally, no. The design just isn't optimized for those constant high-stress loads in the same way a dedicated frame is. It puts too much stress on the integrated body structure over time.
Okay, that paints a clear picture of the trade-offs. So just to kind of wrap our heads around the core differences here.
Yeah, let's recap.
Body on frame, separate, strong ladder frame, great for toughness, towing, heavy loads, often easier to modify or repair in some ways, but heavier, potentially less fuel efficient, and the ride might feel a bit less refined. Think trucks. Big traditional SUVs.
And then unibody. Integrated body and frame structure. Lighter weight, which helps fuel economy and performance. Generally smoother ride, better handling dynamics, and excels at crash energy absorption through crumple zones. Dominates cars and crossover SUVs.
But the downside is potentially complex and expensive repairs after a major hit, and it's less suited for really heavy-duty work.
That sums it up pretty well. Two different philosophies for different priorities.
So now, hopefully, you listening can maybe look at the cars around you a bit differently, or even your own car.
Yeah, think about what it's designed for. Is it a workhorse truck?
Yeah.
Or a family sedan or crossover?
And based on what we've talked about, the pros and cons, you can probably guess which type of chassis it has and understand why the manufacturer made that choice, right?
Exactly. It usually comes down to the intended purpose of the vehicle.
Definitely. And, just as a final thought to chew on, vehicle design is always evolving, isn't it?
Constantly.
So thinking ahead, how might chassis technology keep changing? Especially with, electric vehicles becoming more common, autonomous driving on the horizon, what might the next evolution of the vehicle's fundamental structure look like?
That's a great question. New materials, maybe different ways of integrating battery packs structurally. It's definitely something to keep an eye on. How do you build strength and safety efficiently in these new contexts?
Lots to think about there. A fascinating topic for sure.